Welcome to the study of hydrology. In the last session, we have studied about hydrological cycle, the process involved in it, where the precipitation results and how it plays an important role. So in today's topic, we'll be discussing about the precipitation, how precipitation occurs in nature and the forms of precipitation. There are different forms of precipitation. So that we'll be studying here. And next is the types of precipitation and also the precipitation in India, how rainfall occurs in India. And last, that will be a multiple choice question test. So now coming to precipitation. What do you mean by precipitation? So precipitation in general terms, we call it as a rainfall generally. So when we go into more technical terms, precipitation is generally defined in hydrology that in any form of water like rain, snow, hail, and sleet, which is derived from the atmospheric vapor falling to the ground. Water that may fall on the ground in any of these forms, then we call it as a precipitation. Or in more general terms, whatever water reaches to earth from the atmosphere, we call it as a precipitation. It is nothing but the falling of water from sky in different forms. So all forms of water that reach the surface of the earth from the atmosphere, we call it as a precipitation. But of all these forms, rainfall is the major form which falls on the ground, and that mainly causes the flow in the streams, and hence rainfall is used synonymously with precipitation. Synonymously means when we talk about precipitation, the term that comes into our mind is it is rainfall in generally, and the magnitude of rainfall varies with reference to both space and time, and it is random in nature. So however, to form precipitation, the following condition should be present. For the rainfall to occur, there should be such conditions for the rainfall to occur. That is, the atmosphere must have moisture, there must be the moisture present in the atmosphere, and also there must be a sufficient nuclei to aid that condensation process. We have already talked about the condensation process in hydrological cycle. So to initiate that condensation process, there must be sufficient nuclei in the atmosphere. And third one is weather condition. Weather condition must be good enough to support the condensation of water vapor. And then the products of condensation must reach the ground. So this is how generally the precipitation occurs in nature. So we already know that how the precipitation occurs in nature. Now coming to different forms of precipitation. We have already said that precipitation in generally or synonymously we call it as a rainfall. But technically, precipitation occurs in different forms. It may be in the form of rain, snow, sleet, or hail. So then how can you differentiate between all these four? Generally, we say that rain is the precipitation of liquid water in which the drops are generally larger than 0.5 mm in size. If the droplets of water size is more than 0.5 mm, then we say that it is a rain. So coming to snow. Snow is nothing but you can see from the image that how the snow is falling on the ground. I think you can see the white patches on the ground. So that is nothing but snow. So snow is nothing but it is made up of ice crystals. These are caused when air temperature is so cold that vapor changes directly to ice. And precipitation in the form of ice crystal, we call it as snow. It is another important form of precipitation. And coming to sleet. Sleet, I think you can see the images, the translucent crystals, small crystals. These are sleets, or you can call it as pellets. So precipitation of transparent or translucent pellets of size of ice whose size varies from 1 mm to 4 mm, which are generally round or may be irregular, and these are hard grains of ice consisting of frozen raindrops. Generally in Canada, I think we call it as anekalo. So next is hail. So hail, again, precipitation in the form of small balls or other pieces of ice falling separately or frozen together in irregular lumps. So these are generally associated with thunderstorms, and size of these ice pellets vary from 5 mm to 8 mm. So generally snow and hail are one and the same, but you can classify them as separately depending upon their droplet size. And again, there are many other forms of precipitation, that is drizzle. Drizzle is nothing but where the droplet size is less than 0.5 mm. Drizzling is nothing but we say that you will never call it as a rain, but say there is a slight showering of raindrops. And then you can also see that dew. Dew is nothing but it is formed on the earth's surface due to condensation as a result of cool surfacing during night. And also you can talk about fog. This fog is nothing but it is a thin cloud of varying size formed at the earth's surface. And usually we see it in the morning during winter season. And again frost. Frost is nothing but it is the feathering deposit of ice that is formed on the surfaces. So these are some of the forms of precipitation. So when we have talked about all these forms, but when we talk about sleet, hail, these generally take place in freezing atmospheric conditions. Sleet is often experienced during thunderstorms and is generally accompanied from like white deposit, which we call it as sleets here. So hail is also one such thing, which is generally it is found in small balls or irregular lumps of ice that generally fall during a thunderstorms. And hail is purely a solid precipitation. So coming to mechanism of precipitation, generally precipitation occurs by three mechanisms. That is, first one is lifting and cooling of air mass. So lifting and cooling of air mass is nothing but lifting of air mass to higher altitudes, which causes the cooling of air. And for the precipitation to take place, it is first necessary for a portion of the atmosphere to be cooled until the air is saturated with water vapor. So this is the first mechanism. And second is condensation. That is nothing but conversion of water vapor into liquid droplets. So it is nothing but the formation of minute droplets which are visible collectively in the form of clouds, or it may be in the form of fog. So this is condensation. We have already studied this in the hydrological cycle, where sun is the main driving force for the condensation process. And third one is droplet formation. This droplet formation is growth of droplet is required if the liquid water present in a cloud is to reach ground against the lifting mechanism of air. That is, these droplets will not form into raindrops themselves and may remain indefinitely as droplets in the state of colloidal suspension. So, raindrops or other forms of precipitation which results when minute droplets of moisture collect on particles in the air, which are generally hygroscopic nuclei. And the most common hygroscopic nuclei are salt particles from oceans and products of combination in the atmosphere. Hence, these three methods, lifting of air mass, cooling, condensation, and then it results in precipitation. So now coming to the types of precipitation, we have already studied the mechanism of precipitation. So now coming to types of precipitation, that is for the occurrence of precipitation or precipitation to occur, the following there are four basic conditions that has to be fulfilled. That is occurrence and accumulation of moisture. There should be sufficient accumulation of moisture in the atmosphere. And second one is that is cooling of warm air mass to dew point temperature to produce saturation condition. And third one is condensation in the presence of nuclei. And the last one is that is growth of small droplets to precipitable sizes. So based on the mechanism of cooling, the precipitation are classified into following types. That is convective precipitation, orographic precipitation, cyclonic precipitation. Under cyclonic, we have frontal and non-frontal. And in frontal, again we classify it as cold front and warm front. Now coming to convective precipitation. Convective precipitation, it generally results from the heating of the Earth's surface. So due to heating up of air mass near the surface of the Earth, the vertical instability is caused, and this is because of localized distinct air masses. The warmer air rises vertically as a result of low density, and it is replaced by cool air mass. During the process of vertical movement, the warm air cools and the moisture condenses into clouds and it results in precipitation. So you can see in the above figure that the arrow marks indicate the lifting of the warm air masses, the formation of clouds, which results in precipitation. Convective precipitation lasts for short duration for up to 1 hour, causing intense rainfall with even sometimes with thunders. So the areal extent of such precipitation is generally about 10 km diameter. So these precipitation occurs usually during summer season, that is March to May. And next, coming to orographic precipitation. Now coming to orographic precipitation, it is one of the most important precipitation and is responsible for most of the heavy rains in India. It generally results when mountains force the moist air of ocean to rise. The blue color here shown in the image is the ocean. Generally, the warm moist air rises up when it is struck up by a barrier. You can see the mountain with the red color in the slide here. So it is generally orographic precipitation. It is caused by air masses which strike to some natural topographic barriers that may be in the form of mountains or any kind of barriers, hills, where the air cannot move forward and hence it starts rising up. And as this air rises, it cools. It cools and moisture condenses into clouds and precipitates. Hence, windward side get heavy rain than the leeward side. That is, the precipitation is greater in the windward side of the barrier when you compare it with the leeward side of the barrier. So the rainfall is generally composed of showers and steady rainfall. So you can see in the image that the cloud formation takes place after condensation, and the mountain that is on the windward side of the mountain, it receives heavy rainfall, whereas on the backward side of the mountain, that is on the right side, there is a little rainfall. So windward side is the left side, whereas leeward side, or what we call it as a backward side, receives very short amount of rainfall. So this precipitation is generally occurs in southern slope of Himalayas, which is a good example for orographic precipitation. So similarly, when winds coming from ocean strike the western slopes of coastal ranges, it causes heavy rains. One such best example is the Western Ghats. Western Ghats are the perfect example of orographic rainfall in India. This can also be found in Meghalayas and also the foothills of Himalayas also. So now coming to cyclonic precipitation. So cyclonic precipitation, generally we call it as these are non-frontal type of precipitation, and these are generally associated with lifting of air mass due to pressure difference. And this is due to low pressure. That is, air flows horizontally and causing the air to lift. So this cyclonic precipitation can be classified into two types, where that is one is frontal and the other one is non-frontal. So coming to frontal precipitation, so frontal or front is an interface between two distinct air masses. You can see in the above slide, that is, there are two different air masses here. One is warm one and the other one is cold front. So the surface, what you call it as the surface separating to the two fronts, you call it as a frontal surface. And when a warm air meets the cold air, that is, the warm air behind the front is slowly overtaking the cold air ahead of the front, which is moving more slowly in the same direction. You can see the arrow mark here, and it is represented with the numbers, that is 1, 2, 3, 4. Slowly, the warm air pushes the cold air and it slowly start lifting up. So this, as this warm air rises, the warmer air due to lower density climbs over the colder air as it moves, and then it condenses and results in precipitation. As a result of its increased altitude, it suddenly cools off and its moisture condenses, forming clouds, and possibly again it results in a precipitation. So now coming to warm front precipitation. In the above slide, you can see the warm front precipitation here. So the warm front, it pushes the cold air, and the warm air behind the front is slowly overtaking the cold air, which is moving more slowly in the same direction. And this warm air slowly rises up, and the warmer air due to lower density it climbs, and colder air as climbs over the colder air as it moves down. You can see the red symbol, that is the direction of frontal movement here, so which is generally represented with half circle in the image. So as the warm air due to lower density climbs up, it condenses and then it results in precipitation. So now coming to cold front precipitation. So cold front precipitation, it is nothing but it occurs when a cold air mass overtakes a warm air mass. That is, cold air pushes the warmer air. Cold air being denser in nature, or it is denser than warm air, so the cold air mass remains close to the ground. Since it is denser, it remains close to the ground and moves underneath the warm air mass. It just moves below the warm air mass. So you can see the figure that receding warm air ahead of the cold front. And it is generally seen with the triangles. Cold front is seen with the blue triangles. So now slowly the cold air mass forces the warm air mass to rise here. That is advancing cold air behind the cold front. And as it rises along the front, it produces a steep frontal boundary. You can see the boundary. Blue line indicates the frontal boundary. So this cold front usually move quickly and these are relatively steep. So the warm air mass is often lifted rapidly. So this rapid rise of warm air often produces cumulus clouds. Cumulus clouds means a bunch of clouds. And this cold fronts often bring strong winds, severe thunderstorms, and large amounts of precipitation. The slope of cold front is steep and it travels quickly. So the severe weather usually lasts only for a short time. And after the front passes, skies get cleared off and the temperature drops. So this particular figure, I think you can see the cold front precipitation here. How the cold air overtakes the warm air here. Now coming to non-frontal precipitation. So this non-frontal precipitation is that is the moist warm air meets the cold air. Warm air meeting the cold air. So in this case of non-frontal precipitation, the moist warm air is the moist warm air mass is stationary and the moving cold air mass meets it. So when these meets, there is a passive ascent of warm air over cold air. And thus, due to this, the lightness of the warm air mass, there is a passive ascent of warm air over the cold air. Owing to this active undercutting, the lifted warm air cools down at higher altitudes and later on it results in precipitation. So here in the figure you can see, so the warm air mass meets the cold air, there is a passive ascent that is lifting of warm air or cold air, and it leads to the formation of clouds at higher altitudes. Now coming to precipitation in India. So in India, generally we say that the weather is divided into 4 seasons, that is southwest monsoon from June to September, and post monsoon, that is from October to November, and cold weather season, that is December to February, and hot weather season, that is from March to May. So in southwest monsoon, it generally consists of two currents which originate in South Bay of Bengal and Arabian Sea. And in post monsoon, that is from October to November, tropical cyclonic precipitation occur. In the post monsoon period, as the southwest monsoon retreats, storms due to tropical cyclonic disturbance develop in the south and central bay. They are observed to move in any of the following path, that is northeast, southwest and southeast. And third, coming to cold weather season, that is winter, that is from December to February, This is the season during which fine weather prevails over the entire country. Southern and east coast are occasionally subjected to cyclones, and hence north will experience the cold wave. And coming to hot weather season, that is during summer from March to May, during this season the temperature is on the rise, reaching the highest value in the month of mid-May. So the depression and the cyclonic storm start developing both in the central Bay of Bengal and southwest Arabian Sea. So with this we come to the end of today's session. So we have almost all covered the precipitation, the different forms of precipitation, how it occurs in nature, and different precipitation forms and types of precipitation, that is convective, orographic, and cyclonic. And now we'll have a small test, that is the last part of this session. So the first question is, which of the following is not a form of precipitation? That is rainfall, waterfall, dew, or fog. The answer is B, that is waterfall. Because rainfall, dew, fog, as I have already said, that all these three are the forms of precipitation. And now coming to hails. Hails are nothing but the falling of. We have already seen in the image that there are different forms of precipitation. So hails are one such. So the choices here given are, that is water, lumps, vapors, and rain. So hails are generally fall on the ground in the form of lumps. There is, when we see the different forms of precipitation, we have seen in the images that the hails and sleet are one and the same, but they vary in their sizes. And generally hails fall in lumps with the translucent ice pellets. So the answer is B. Now coming to the third question, that is rain shadow effect is associated with cyclonic rainfall, orographic rainfall, convectional rainfall, or frontal rainfall. So the answer is B, that is orographic. We have seen that whenever the hot air mass gets struck up by a barrier like mountains, they get lifted up due to condensation that results in rainfall. So hence we say that the windward side get more rainfall than the leeward side. This is rain shadow effect. So the answer is B. Now coming to the fourth question, that is frontal rain is caused by convection current, winds from sea, cyclonic activity, or condensation of water evaporated from mountains. Here the answer is C, that is cyclonic activity, because frontal rain is caused by cyclonic activity. Under cyclonic we have classified frontal and the other one is non-frontal. So the answer is C, that is cyclonic activity. And coming to the last question, that is water falling on the earth's surface in any form is called atmosphere, precipitation, climate, and weather. So water falling in any form, we call it as a precipitation, that is P. So with this we come to the end of today's session.